So in this example, you don't have infinity as a limit. You have the function value becomes infinite somewhere. And it's pretty easy to see that at x equals 0, we're going to have an undefined denominator here. All right, so let's go ahead and, so the way we need to split this one up is we need to say we're going to take the limit this time as a approaches 0 from the right. So we're going to replace this with a limit, basically, of the integral from a to 4 of e to the negative square root x over square root x dx. Then the next thing we need to consider is how we're going to do this integral. Well, this is a u substitution. We're going to use u equals negative square root x. So du equals, it's going to be negative 1/2 x to the negative 1/2, right? So this is equals negative x to the 1/2. All right, so then my du is going to be negative 1/2 x to the negative 1/2. Or I could say, just to put it in terms where it's recognizable with what we have here, sort of compatible, this negative 2 du equals 1 over the square root x dx, because x to the negative 1/2 is 1 over square root x. All right, then I see that the 1 over square root x dx is the 1 over square root x dx here. So that means that this integral becomes the integral from a to 4 of just e to the u du, but with this negative 2 out here. All right, so I have the limit as a approaches 0 from the right of this integral. Yeah, I could pull the negative 2 out to the front at any point. I guess I'll do it here. This is not where I did it when I worked this out ahead of time, but let's shake it up a little. All right, so this is going to be, the antiderivative is just e to the u from a to 4. So I'm going to have, I like pulling the negative 2 out first. So I have negative 2, right. I need to substitute the x back in. So a approaches 0 from the right of e to the, our u is negative square root x, so negative square root x from a to 4. So that equals, let's see. Yeah, so I think what I'm going to do this time is consider that when I plug in the 4, I'm not going to need the limit. So let's go ahead and plug in the 4, so I'm going to have e to the negative 2, right, when I plug in the 4. And the limit's only going to apply when I plug in the a. So I usually break this out as a separate step, but I'm not this time. So limit as a approaches 0 from the right of e to the negative, and I'm plugging in the a now, so square root a. Yeah, that looks good. All right, so now I have to, I can do negative 2 e to the negative 2. I need to think about this limit. So what's going on? A is approaching 0 from the right. So that means the square root of a is approaching 0, right? Sometimes we'll note little bits of it like a is approaching square root of 0. Therefore, my e to the a is approaching e to the 0, so it's approaching 1. Right? So when I distribute the negative 2 times the negative 1, I'm going to get plus 2. Yeah. That's what that is. That's what that area is. I think that one was interesting enough. I think I made a graph of it. If not, I guess that's just life. Let's see. No, I don't have a graph of that one. All right, it's pretty interesting though. Anyway, that's what it is. Because I think I really only want to do one more example. I think I can squeeze it into this video, make this the last video. So we're going to do number 30. So number 30 is the integral from negative 1 to 4 of dx over square root absolute value of x. So, they put the dx up here just to be fancy or something. So this one you have to look at and really think, how would I even know that this is an improper integral by looking at it? Where's the discontinuity? The discontinuity is when x equals 0, because the denominator will be undefined. All right. Is that x equals 0 within my limits of integration? It is. X equals 0 is between negative 1 and 4. So there's some kind of a vertical asymptote. The square root of absolute value of x. We could probably figure out what that looks like. So it's not that hard because we know what square root of x is. And then square root of negative x would just be a reflection over the y-axis. Oh, but it's 1 over that. Yeah, 1 over that. So, but interesting things I think you could sort of figure out. It's going to be like this is square root of x, but I'm going to have 1 over it. So as this gets larger, this gets smaller. So the 1 over square root of x is going to have to go like that. But so interesting things by looking at square root of absolute value of x, I know everything's positive. So this is what 1 over square, just roughly speaking, that's what 1 over square root absolute value x looks like. And I'm integrating from -1 to 4. And if you have ascertained what the pattern is about when these volumes are finite, or these areas are finite, and when they're infinite, this one's infinite because of what that exponent is. I think we're going to look at that in more detail later. All right, so what do I do with this? So I split it up over that asymptote. So I'm going to call this the integral from -1 to 0. So you just split out your problematic limit of integration and turn that into a limit. Then plus the integral from 0 to 4 of dx over square root absolute value of x. All right, now we'll rewrite these integrals, and like you can't just integrate absolute value. That's not an easy thing to do. But so if I ever want to integrate an absolute value, what I need to do is split the integral into its positive and negative parts, which I've sort of done already anyway. So what I can do is look at this one. Let's go ahead and make this a limit as we want our b to be approaching 0, but from the left. So limit as b approaches 0 from the left of the integral from -1 to b. And then I'm going to rewrite this part in here. So here's the thing. From -1 to 0, x is a negative number. That means the absolute value of x is -x. And then I have to the -1/2 power. So -x to the -1/2 power dx is what that integral really is. And then for this one, I'm going to have, I want to consider as the a, right, so this is a, this is b, as the a is approaching 0, but from the right. So limit as a approaches 0 from the right of the integral from a to 4. And over here, on this side of the y-axis, the absolute value of x is a positive number, so the absolute value of x is just x. So 1 over square root absolute value of x is just 1 over square root x. So I really just have x to the -1/2 dx here. All right? So that's how we got to split this up over our undefined point at x equals 0. So then we can go, this is the limit as b approaches 0 from the left. Our antiderivative now is going to be -2 times -x to the +1/2 power. Let's figure out that. Let me know if you have questions on it, but you should be able to do that. And then we have limit as a approaches 0 from the right of just 2x to the 1/2 power from a to 4. Okay, so now we should go split these up in terms of the limits. When I put in the b, I'm going to have the limit as b approaches 0 from the left of -2 square root of -b. Yeah, that's what that is. And then it's going to be, I'm still doing this with the upper limit. Now I'm going to go minus the lower limit. The lower limit is going to be a constant, so it's not going to need the limit. So when we're using the word limit in two different ways, here and here. So when I do, when I substitute this -1, I don't need this limit out here. So I'm going to have -1, which is 1, square root of 1 times -2, and then I'm going to subtract that, so I get +2 for when I plug in the -1. Right, so all of this stuff here is this stuff. Go through that with a fine-tooth comb if you need to, but I think it's fairly clear. Now when I do this one, I'm going to put in the 4 first. So the 4 is the one that's not going to depend on the limit. So I'm not even going to write the limit. I'm just going to go 2 times square root of 4. That's 2 times 2, that's 4. All right, and then I have to do plus, it's actually minus the limit as a approaches 0 from the right of 2 square root a. All right, now I just got to look at these limits. Okay, so for this one, so it's interesting, b approaches 0 from the left, so b is a negative number. And then I take the opposite of it, so I get a positive number, so I can take the square root of it. But it's a number that's approaching 0, so as b approaches 0, the square root of 0 approaches 0. 2 times 0 is 0, it's all 0. 0 plus 2 plus, that's weird, 4. And then here I have limit. I like to work these things out beforehand, but like make so many mistakes that like why bother? I'm just better off just doing it by hand. I did 2 times 2 is 2. I just didn't even do the 2 times 2, right? It's 4, square root of 4 is 2, times 2 is 4. I put 2 there in my work. I actually wrote the 2 times 2, and then I said it was 2 anyway. It's hilarious. All right, anyway, this one, a is approaching 0 from the right, so the a is a positive number, so we can take the square root of it. But since the a is approaching 0, the square root of a is approaching 0, 2 times 0 is approaching 0, we have minus 0, and that area is 6. Yup, there you go. How many donuts in half a dozen donuts? The integral from -1 to 4 of dx over square root absolute value of x. That's how many. Okay, your homework, I think I already stated somewhere here. Did I state your homework somewhere? Anyway, it's posted somewhere. It's not very much. I hate to waste time on this video hunting for the homework that's just going to be posted anyway. I think what I did was write this in the wrong notebook. All right, so anyway, your homework is, here you go. It's here. I used the wrong notebook. All right, that's it. That's your homework. It's not very many problems. Have a ball with it.